I'll try to explain the heart of light processes. So basically how actually the platform handles them internally. First, I will show you what light processes are. So I'll try to explain what light processes are, followed by how can you actually use them. We're going through a couple of scenarios that on which you would want to use light processes, and then I will also try to explain in an easy way how the platform handles them internally. I'll go through what actually happens whenever there is an exception during the course of the light process execution. And also I'll go through some best practices that I actually find very useful when dealing with light processes. I'll end up with a live demonstration of all the topics that I've explained during the course of this session. And then I will present a summary of everything that we've talked in a very condensed way, which I'll be able to answer all the questions that you would have during the course of these sessions of this session. So starting, what actually are light processes? So basically, light processes are background transactions triggered via the database. And there can be up to 20 parallel transactions running at the same time for each front end. So if you have like a production environment with 2, 3, 4 front ends, then that's like a 4 times 20. And then that's the number of parallel transactions that you have. Just because each front end will have by default 20 parallel 20 threads available to run this type of processes. Each transaction has a timeout of 3 minutes for light processes, and contrary to timers or BPT, light processes do not record execution logs. So timers and BPTs, you can go to Service Center and see whenever they ran, what actually happened. But for light processes, there is nothing that you can see. So you have to actually try to do that yourself if you want. Now, comparing these three different background processing methods, you should use timers for kind of recurrent schedulable tasks or for very heavy batch processing stuff. And that, well, just because a timer has a 20 minutes timeout, so is the only one with such a big timeout. BPTs, on the other hand, actually you should use them to create process workflows like a payment authorization flow, and which you can make use of all these different type of available activities like human activities, wait activities, automatic, and so on. Light processes should be used to execute ad hoc tasks in the background, like and also due to the speed and the number of transactions available for this, light processes are actually great to use on a very high throughput system like a message queuing system that exchanges information. But actually, I'll go through this in a later in this session. Now, actually, how can you use them? Well, to start, to actually activate this, you have to go first to Service Center and to go to the module that contains the process that you want. And under that module, you would have the Operations tab, which you'll be able to go and you'll see a light process execution flag, a toggle that you can just check and save. At that moment, if that module has processes that are eligible to be light processes, whenever you deploy them, then you will see it. But then to create the light process itself, you go on your module, you create a BPT process, and then inside that BPT process, you can only have one automatic activity. So if you have more activities, or if you, so that it would not be considered as a light process, and it will be just considered as a normal BPT. Then this process must be launched via a create entity. So on the process, you can set the launch on property where you can select an entity. And whenever you insert a record on that entity, then a process will start. Then you simply publish your module. So whenever you publish it, then during the deployment phase, if everything goes right, and if your process actually meet all the criteria to be a light process, then on the deployment phase, on the message part, you will see a message saying that your process will be executed as a light process, and that will not record any history. But actually, I will also show this later in the process. Now, in which scenarios you want to use them? So there's a couple of scenarios that I'll just show. For example, to generate ad hoc reports. In this case, we are a user that we have a dashboard and we want to generate a report. I can click the button, and then the moment that I click, the only thing that I'm doing is actually inserting a record on an entity and then showing a message to the user that the report will be generated in the background, and then you will be receiving an email with that report. Then in the system, what happens is the moment that you insert a record on that entity, a background will be triggered in the background, and then that light process will be responsible to execute the logic of generating that report, like querying all the information needed and so on. Because this information, the generation of this report can take a while. And if you put that on the request of the user, then the user probably will not have a good experience throughout your application, since it will have the slow feeling while navigating through it, or by doing these heavy tasks there. Another maybe a bit more complex scenario that you would want to use it is kind of a message queuing. So imagine an application that exchanges information with external systems using kind of a publish subscribe mechanism, which is just a way for an application to publish a message and other applications to subscribe to that message. This application would be constantly sending out and receiving big payloads, and processing those big payloads can actually be very heavy. And if not done properly, it can take a hit on the server's performance, especially when the server is receiving a lot of messages in a given moment. To try to solve this problem, we can actually create kind of a messaging queuing system that your application basically exposes an API to receive a message from an external system. And when an external system calls this API, that API would simply serialize the input structure to JSON and store it, and then trigger a light process that would, in the background, deserialize the JSON back to structure, and then do the heavy lifting of processing all that received information. The same thing can be done for outgoing messages. So whenever you want to send big data, a lot of data to external systems. So a user do something in your application that will trigger a light process in the background. And that light process would be querying all the information needed to build that message that would be sent out to the external systems. That would also give the user a good experience, since he would not have to wait for the system to perform that heavy task on his request. But also it would prevent the user to receive error messages to the external systems being down. And using light processes, if an external system is down, then light process would get an exception and retry moments later. Since light processes already have retrying mechanisms built by nature, then this would be actually done very easily. And by doing something like this, if in a given moment the system starts receiving an abnormal number of messages, then the light process would automatically start queuing, and all the threads, if all the threads were being used at the same time, then it would automatically start picking up those queued messages whenever threads start to become available. And well, to make this approach more robust and efficient, you could extend the entity used to trigger this light process with like a number of times that the light process failed, or an error message, and then you can keep control of the last time that it failed. Why did it fail? How many times did it fail? And but actually, I will also show this a little bit more further in this session. But now, how actually does the platform handles these light processes internally? So actually, to start, the platform server has a scheduler service, so a service that is called scheduler service, that keeps pinging an OutSystems table called OSDC BPM event, searching for records in the past So yeah, so and if we actually look here, we have the OSIS BPM event table, and then the scheduler keeps looking at this entity to see if there are records with the next run in the past, so lower or equal than the current date time. Once a record is found, then the scheduler search for an available thread and then allocates the record found to one of those available threads. The thread responsible to handle that record then we'll look at the process definition ID to know the process that has the logic to execute. So if we look at this record that a thread would be picking, the thread would be looking at this process definition ID to know what process to execute. And then also by looking at this process, it can know what entity was used to trigger that process. So now the OSIS BPM entity, the process BPM event entity also has the entity record ID here. And that corresponds to the inserted record on the entity used to trigger the light process. And now the thread have all the ingredients required to be able to execute. Then you can see that the OSIS BPM event records are being picked up by the threads. Sorry. You can see what OSIS BPM event records are being picked up by the thread by going into the environment health. So in monitoring, environment health, and then under the environment health, you will have the list of front ends available for your environment. And then for each front end in front, you will have the detail link under the scheduler column. And if you click on it, you can see the scheduler service details page. And on this page, you can see all the threads from timers, from BPTs, and from light processes. And then for a given thread, you can also see its status and what event is being picked up by that thread. So in this case, we have a light event processor thread that is processing an event ID with 1350999, which is actually this one, 1350999. And then we know what process it corresponds and what entity record it also corresponds. And then we can backtrack everything and know exactly what is actually happening here. Then, but actually, before we go, to insert some for the scheduler to that is constantly pinging this OSIS BPM event table, how did actually the record went there? So how did it end up in that entity? So this is what I will try to explain here. But before actually I'll go to this slide, I will try to give some context. So on this specific scenario, we have a light process that is launched whenever there is a record inserted on this gen report trigger. Oh, let's see if I can, oops. This is actually occupying some part of the screen that I don't want, but I don't know, push it here. I don't know why it's there. Okay. So in this scenario, every time that I insert a record on this entity, gen report trigger, then I want to trigger a light process. Well, to do this, in Service Center, we need to select this entity on the launch on process property of the process. But also to be able to select this entity on the launch on, I also need to go to the details of that entity and then select and toggle expose process events toggle for that specific entity. And at that moment, that entity would be available to select on the process. I will also show this afterwards, of course. Also, by checking that toggle on that entity, whenever you publish your module, then the platform will create an event table related to this entity. And actually, you can see this by querying this OSIS entity table, and you can select the physical table name and event table name, so you can know the tables that are related to this entity. So just to explain, the OSIS entity table is a system table that holds all the information for all the entities created in OutSystems. The physical table name holds the name of the SQL table that holds information of your entity. So by querying this physical table name, which is the OS user 261 gen report trigger, which is actually this one, by querying this is the same thing as you querying this entity in your Service Studio. But then Service Studio will translate to the physical table name in runtime, and then you will have something like this. And then you have your event table. The event table is the table that holds the information that will be used to populate the OSIS BPM event table that I've explained on the previous slide. So this OSIS BPM event table is a table that the scheduler keeps pinging to know if there is something to do. Now, the module, while the module containing the light process is being published, the deploying step will create these event tables that I've explained before, because that entity has the expose process events. Then the publish deploying step. So when you publish, the deploying step will check what processes have the launch on property defined, and create one record on the event table for each of those processes. So here I only have one process that will be launched whenever a record is inserted on this entity. So then this event table will only have one record related to that process. We can see that on the process def ID. This process def ID is basically the process definition that corresponds to the process that you created in your module. If you'd have two different processes that would be triggered whenever you insert a record on this entity, then here you would have two records on this event table. Still on the deploying step, or when you publish your module, deploying step, the platform will also create a trigger in the entity that on this entity. So on the gen report trigger. In this case, it would be on this one, on the user table, and the trigger will be created on this specific table. This trigger will be used to insert on this OSIS BPM event by querying the event table together with inserted records on the entity, which means that whenever here I insert a record on the gen report trigger, SQL will start running this script, this trigger script, which then it will look for a record on the event table, which is light. So this light flag is to know if the process is eligible to be light process or not. Because if I would have a process that would have more than one activity, then this is light flag will be false, and then this would be a normal BPT process. But here it will search for one with is light true, so that is a light process, and then it will insert on a record on this OSIS BPM event table, which will have the space ID from the event table, the tenant in case in case your entity is a multi-tenant entity, so that would also pass the tenant, so the light process knows which tenant in which tenant context it should execute. Activity will not have anything because light processes don't store anything, so there is no activities actually. And then the process definition would also be passed on to the OSIS BPM event. Entity record ID would have the inserted ID on your entity. Get date would be set on the in-queue time, and basically whenever it was created on this OSIS BPM event, because OSIS BPM event is nothing more than a queuing table used by the platform, and that which then the scheduler checks if there is something to do. Error count is set to 0, and then whenever it fails, then the error count will increase, and get date will be set on the next run, because then the scheduler will check if there is any record with the next run before now, and if so, it will pick that record. And that's basically how actually the platform does this to set the record on this OSDC BPM event table, and then the scheduler can pick it up. But then, excuse me. But then actually, what if something goes wrong? So how does the platform react to this? So basically, if there is an exception during the course of the light process execution, then the first thing that the platform will be to increase the error count by 1. And then it will calculate the next run based on this error count. And the first time that it fails, the only thing that it does is it sets the next run to now plus 1 minute. So it will set 1 minute in the future. But then if it failed more than one time, and in between 1 and 39 times, there will be a constant increase on the next run in between runs. So the first time that it fails, it sets to 60 seconds. The second time, probably 64. The third time, 69 seconds, and so on. And it keeps increasing gradually. But the moment that it fails 40 times, from that point on, it will simply schedule it for the next day. So if it fails again, just schedule it for the next day, and so on. And it will always be the next day. So some good practices that you should consider while building light processes is actually considering that light processes don't hold any logging data, then somehow you need to control whatever is happening, because everything is going in the background and you don't know what is going on. So to try to understand this, the first thing that you should do is not use business entities to launch light processes, but use specialized trigger entities instead. Imagine that you create an order, and whenever you create an order, you want to trigger a light process, but then there is something that happens with that light processes that stopped, and you want to stop it. Otherwise, it keeps retrying forever with errors. But then you want to actually trigger again another light process for the same order. If you'd use the order entity to trigger the light process, then you would have to create another record on the order to create another light process. You don't want that. So you would create probably a order trigger, something like that, which would have the order ID. And then you simply insert on that trigger entity. So insert the first time, and the light process runs. If you want to stop it, you stop it. But then if you want to run it again, you simply insert another record on this trigger entity, and then another light process will run for the same order. Another thing that you should consider is adding some other fields to your trigger entity. One of those fields is error count, because then you can also know how many times that it fails. Because here I can see that if I have an exception while executing this light process, then while handling that exception, I can see if it fails more than 10 times, and if so, I simply end the light process without any error. But if it already went for more than but if it did not fail 10 times yet, then I just want to throw an exception. Of course, I want to commit before throwing the exception, because I'm actually updating the trigger entity with this data. And probably this throw exception will also abort. So before aborting, you should want to commit this. Another thing is error message, because if you store the error message from the last time that it failed, then you can also just query this entity and see what was the reason that that specific light process failed. Another thing is have a flag like is finalized, so you know if that light process finished successfully. Because then I can simply, so the moment that you execute your light process, in the end, you update the is finalized to true and update. But while it keeps failing, then this is finalized is still false, which means that you can simply query this entity and see what light processes are running and which ones are not. And the ones that are not, why did they fail, by looking at this error message um, attribute on the trigger entity. Now I'll try to do a demonstration of this that I've just mentioned. So starting, we have here we have here an application, and I have my own dashboard. And now I want to generate a report from my own dashboard. And okay, in the meantime, I also my session expired, and of course, because it's a live demo, it will not work. Oh, let me just. Okay, now we are there. So I have my application, which I have my dashboard, and when I click on the generate report, then what is actually happening is the platform is the application is generating a report in the background, so it can then I'm presenting with the download. But well, I got a timeout because that generation actually takes a while. So maybe we should change the approach of generating this report, and instead maybe let's do that via a light process in the background, and then receive an email in the end. So in this case, I have my application, I have my button, and this button is now just generating the report and downloading it. What I will do instead is I'll create a live process. Well, actually, before I do this, there is something very important to do, which is go to that module and activate the light process execution. So I go to my module, go to the Operations tab, light process execution, enable, apply. And now, once I publish my module that contains light process, then it will check the processes that are eligible to be light processes. So now I have my process, which I will call generate report, and then this process must have an automatic activity, only one, and here I will call it process report. Now I want this process to be launched whenever I have an insert on an entity. I already created an entity called gen report trigger, and I want to have this to trigger my light processes. So I just come here and I want to select that entity, but well, I don't have that entity available, because first I need to go to my entity and select on the edit entity the expose process events. And now this tells the platform to also create the event table whenever I publish, and then it goes to deployment step, and then it will check the tables that have these expose process events and create the event table for it. So now that I have selected that, I have that available. Now, whenever I insert a record on that entity, then this process will be triggered. I also need to change my screen, so my button, to, instead of do this, the only thing that it will happen is I want to insert a record there. I already create well, my CRUD action because we should actually wrap our system entity actions. So I created a CRUD action that will receive the user ID, and then it will insert on this entity a record with that user ID, because I want that light process will to create a report for this user. So with this user ID, it will know which user it should go with. So now I go to that generate report, and then create a record on this entity, sending my user, and then I can simply show a message to the user saying that I don't know, report will be generated and will be sent to you by email. Okay. What I should do now is do the logic to generate that report. So here I will, well, the first thing that I should do is actually query the record that was inserted on my generate trigger entity. If you see here, I have an input. So if I put none, I don't have an input, but the moment that I select an entity, I will have the ID from the input from the entity that was responsible to trigger that process. Now that I have access to this, I can simply query it. And now that I query that record that has the user ID, I can generate a report for that user, receiving the user ID from the trigger entity. And then I want to send it by email to that user. So I should select here the email, but I want to access the user table. So I join the user table with the trigger entity so I can have access to the email from the user. So now I have the email, and then on the attachment that I want to send by email, I select the report. And then, as I said before, we have the is finalized flag that I added to this entity. I didn't add the other ones, but the ID is the same. So now I can just simply update this is finalized to true. So let me just do here and assign. And is finalized to true. And okay, here I'm using directly the update, but avoid doing this, and you should wrap your entity actions. And that is it. So I publish this, and okay. And now that I'm publishing, if everything went right during the deploying step, I should see here a message that my process generate report is using light process execution and usury will not be recorded. So until now, everything seems to be fine. One thing that I also want to show you now is directly in SQL, so you know exactly what is happening here. Here in SQL, we can see that when we query the OSDC entity table that I've already explained before, so this holds all the information from the entities from OutSystems. And if we query and search for our gen report trigger entity, then we can see what is the name of the physical table and what is the name of the event table. And we have here the OS user, so OutSystems user, and this OutSystems event, and this one is OutSystems system. By looking at the user, this is basically querying our table that already has a record because I did this before, already has one record there. This is the trigger entity. If we look at it, the event entity, if we look at it, we see what process will actually be triggered by an insert to this entity. And we see here that is the process definition ID 45, which corresponds to the generate report. And we can see that is also light. So when it was deploying, it will check that this process is actually a light process. So it set it to 1. If it saw that there is other type of activities there, it will set it to 0, and then it would be considered a normal BPT process. Another thing that it happened, also one thing is here the OSDC BPM event. So if I create this entity, this table, now there is nothing there because there is nothing for the scheduler to do. One thing that also happens when I deploy and when I publish my space with the launch on for the process set is create a trigger, right? So as I explained before, and to see this, we can go to our database, go to the Object Explorer, and here we go to our catalog for the catalog where you have your data. And then in the catalog, I will search for my user entity because this is the entity that will have the trigger. And now that I have my user entity, I can expand and then see here the triggers, the folder with triggers. And I see here the trigger that was generated by the platform. But now what is the code of this trigger? So if we come here and modify it, then we have access to the code of that trigger. I'm not modifying it, but actually I can see only the code that is there. So I will split this a little bit so it can be a bit more understandable. So let's go into here. I will separate, use the select and another insert, select from, and because when I do modify, then everything is in one line. So then we have to split if we want to see what is actually happening. Let me try to put this a bit more readable. Yeah. So there are two things that happen whenever a record is inserted. Yeah. So there are two things that happen when the record is inserted. So this is a script of the trigger. So when I insert a record on my user table, so on my trigger entity, when I insert a record on my trigger entity, then this script will be executed. Basically, what happens is first it will search for events with isLight false, basically searching for processes that will be BPT processes. But here we are just looking for light processes, so we will look at the second insert. Here is searching for records on the event table with the isLight set to true. And then, so it's the same thing as querying this. So let me bring this select here, so we have it all in the same place. Okay, so basically here, this is selecting for this entity where have the isLight true, and then it will and also have here the inserted record. The inserted will contain the information that was just inserted on this entity. So here is passing to the OSDC BPM event the space present on this event table, the tenant ID. In this case, it's not multi-tenant, so there is no tenant. Activity will always be null because live processes don't have activities. Process definition from the process that corresponds to that process is not an update because it's only when I insert, because we don't have when to start processes. We can never start processes with updates, only with inserts. And then we have the isFlag, well, the flag, sorry, actually this information is not used to send to the OSDC BPM event. Now we're just going through some to other things. And then we use the inserted ID to send to the inserted record ID, to entity record ID attribute, get date for the enqueue time, and get date for the next run and error count. So these are also explained during the slides. So basically this is how actually it works. Now I will just go through the application here, and I will do very quickly here a debug, because then with debug I can show everything happening here. So I'll put a breakpoint here, and I will also put a breakpoint on the CRUD, and then start the debug. And there you go. So it should be opening. Okay, wait here. Let's see. And okay, we have our application. Now that it's in debug mode, or no, it's not. Let me close this and start the debug again. I'll try to be as fast as I can, but I feel that this is very important to show you. Okay, now everything will be all right. Now that I'm debugging, I click on the generate report, and now I have a breakpoint here on my CRUD action. So now I will just continue to here. And now that I continue to here, I created a record on these entities. So if I check in SQL and check in my entity, the transaction is still open, so I need to put with no lock so I can read and commit the data. And now I have here, so my new record is 18. And when I inserted a record here, the trigger ran, and the trigger then inserted a record also on the OSDC BPM event table. And if I see here, we have that new record inserted here with the entity record ID 18, which corresponds to that 18 that was just inserted. And now I will just continue. And now that I continued, if I look at OSDC BPM event, we can see that the next run, the queue time. The queue time is the time that the thread picked that process, because we already have a thread picking that process, and this record has the ID 21. So if I go now to Service Center, if I go now to Service Center monitoring, environment health, and under my front ends, go to the scheduler details, I can see here that we have one thread processing the event ID 21, and then I keep that, I can have that under control. And basically that's how it works. Where is my Service Studio so I can continue debug and stop debug? And going back here, so this is basically how it works. So a small summary: light processes are multi-threaded background transactions. The deployment stage creates SQL triggers and write on the event table, on the BPM event table, when records are added to entities that are used on the launch on property. Scheduler pings that BPM event table to search for records in the past and then assigns a thread to handle them. So so this is here. That is it. So it's time for a Q&A. You have my email and LinkedIn if you need to, if you want to reach to me to have this slide deck available for you. And that is it. So let's go for the questions.
First of all, thank you for your questions. I will try to answer all the questions, starting with the ones most voted and going through all them afterwards. Starting with the first one with 16 votes. Since light processes are not traced by the platform, is it possible to terminate a light process that is constantly failing? For example, in Service Center for normal processes. Actually, no. So you cannot, out of the box, terminate light processes that are executing. What you can do is, so if you prepared in advance and if you have your trigger entity with an attribute called, for example, skip trigger, skip execution, and this will be flex, so boolean, boolean. And in the beginning of your light process, you simply check if that light process execution is true, and if so, you simply end it. This means that if your light process is constantly failing and you want to terminate it, you simply update your record to skip execution to true, and the next time that light process runs, it will see that the skip execution is true and simply ends. If you are already in production and don't want to change your database or your table to have one more attribute directly in production, maybe what you could do is simply create a site property with, for example, a trigger ID skip, and then integer, oops, and then when the light process starts, instead of checking this, because in this specific case you would not still have this one, so you would compare um, this with your trigger ID, which means that if your light process is failing, you could simply download your module that contains the process, create this site property, and create this if, and publish it. Then you could simply set this site property with the ID of the process that you want to skip, and then the next time that the light process starts, it will compare that ID with the one from the query, and it will simply end it. There is another way, which actually it's easier, but you probably don't have access to do that. Depending on if you are on premise, maybe you have. On the cloud, you definitely not. But as I told you before, the OSDC BPM event table is being constantly pinged by the scheduler to know if there is something to pick up, which means that this is the record that you want to that this is a table that you should check the record and delete it, because if you simply delete the record that is responsible for that specific light process, then the scheduler will never pick it up anymore. For this, you just have to know what is the ID from the record that is constantly failing, and then that ID would be on the entity record ID, and then you would also have to check the process definition ID that would have to correspond to the process definition ID from your process. And then if you delete that record, then the scheduler would not pick it up again. The next question. Seems the best practice you explained for handling like processes is overkill, and then you should just use normal processes that are traced by the platform. What do you think? Um, yeah, I don't think so. Just I will try to explain. Okay, starting by how do actually normal processes run? Normal BPT processes run. So whenever you want to trigger, um, imagine that this would be a normal BPT process, and it would trigger this process when you create a record of this entity. What would actually happen is that you would create a new record on an entity called process. That process it would be the instance of the generate report process, and then you would have to create another record on the table called process inputs, and that process inputs will then have the value of this input. Then it would create another record on another table called activity to handle each activity, because these would be actually three independent activities. The start is one activity, the automated activity is another activity, and the end is another activity. So first the start would run, and you might think that, but why actually the start is actually needed? Actually, the running of this start activity is what then will start, for example, some conditional starts that you might have, or if you have, for example, a BPT process that would have, for example, on process start callback, then this would then this callback execution would actually be done after this on start. So this would be the first activity to run. Then the logic for the automatic activity will run, and only after that the end activity will run. The end, this is also another activity which determines how the process will stop. So imagine that you have this simply as it is now, then it will simply close the activity for the end, and then update the process um, instance to closed. But if you have this set to terminate, then during the run of this activity, then it will simply update this process to terminate, and then it would have all the logic to actually terminate everything if you have more activities. For example, imagine that you had here another activity running, and this was still open. And if you would have a terminate here, this would also be terminated. So that would have all the logic to terminate all that thing that was open inside this process. And if you just use this as a light PPT, then actually only this logic runs. There is nothing else. Nothing else. If you run a normal, just this, for example, it maybe take 1 second or 2 seconds, but as a normal BPT. If you run as a light process, it might take maybe 100 milliseconds, 200 milliseconds. Well, actually, it depends on the logic that you have here. But you can believe that actually there is a huge difference in how long it takes to run a normal BPT against a light process. um, how can you limit the number of parallel running processes so that they are actually queued instead of fired all at once? They are actually not fired all at once. If you have one, well, they are not fired all at once because they are all independent, which means that once there is something to pick up, the scheduler would just assign one thread to handle one specific record from the OSIS BPM event. If all of a sudden you have your OSIS BPM event table with a lot of records that are not picked up, then the scheduler will just assign one for each available thread. But they are not being picked up all at once. It's just one by one, depending if there is actually things to pick up. But if you want to limit the number of threads available, then you might have to open a case without system support, so they can to decrease the number of the number of parallel threads for your normal BPT. But I don't believe that you actually that maybe would not be a good idea. 20 threads is really not that much for normal BPT. So think about it. Each thread is simply an execution. So imagine that you have 20 users in your application, and those 20 users press a button at the same time. That's 20 different transactions that are running at the same time. It's the same thing here. So you have 20 threads that are running as, a function at the same time if you would have them running exactly at if all the threads were available to pick exactly the same thing. But that would 20 threads is actually not an issue. Of course, if you have like um, 4 front ends, and then that means that in total you would have around 80 um, 80 threads available, and then you only have one database. So that means that if all the threads are doing things, querying the same tables and doing updates and so on, then actually might take a hit on your SQL performance. So that's what you actually have to think about. Another one. So uh, now, yes, this one. If you fire 21 BPT processes, does the 21st start if one of the 20 has been finished, or does it only start after all the first 20 have been finished? Yeah, so if you have so if all the 20 threads are being used and all of a sudden there is another record inserted on the OSIS BPM event, then that record will just be there until there is one more thread available. The moment that, for example, one thread finishes and now you have 19 threads still being in execution, but you have one thread available, then the scheduler will immediately assign that available thread to that new record. So it does not wait until all of them finished because they are all independent. Next one. In order to ensure you have no issues at all running the BPT in the light version, you try it out first with the normal BPT, right? In order to get the logs in case something goes wrong. How do you usually deal with this? Well, I usually just do it with the light process. I start immediately with light process because if something goes wrong, it will throw an exception and I can see that exception on the error logs. So during development time, I can just go to the error logs and see if something is going wrong. Also, I can query the OSIS BPM event table just to see if my record is there. You can also do this with normal BPT during the development time. So if you just do it with normal BPT and then check in your service center the processes logs and then see if everything is going right, if there is an error or not, and also there you can just have the retry button, which you can click on the retry to automatically update the next run to now. Because if it fails sometimes, then you already have the next run set to like 5 minutes after or 20 minutes after, depends how many times it failed. But and if you already have that in Service Center, you have a button that you can just click to retry now, that it will immediately update the next run to now, and then also helps on your testings. So yes, you might do that. But then once actually you go for testing environment and pre-prod and prod, you might think to change it to a normal BPT. And you can simply just do this by going to Service Center under the Operations tab and then activate the light process execution flag. If you want to go for normal BPT to test it, just uncheck that. The next one, when to use light processes versus BPT. BPT, you should use it for process workflows like as I explained during the session, like a payment authorization flow, which a human activity starts, the user will go to that human activity, it will then do something, and then maybe after that human activity it will start a wait activity that will wait for something like for approval or something like that. And light processes should be used when you want to like trigger an ad hoc background process. So if you are on a screen and you want to trigger something to run on the background that you don't want to make the user to wait for it, or for example if you have yeah, so actually that's actually one of the best use cases. But actually before, light processes did not exist and you only had timers and BPTs, which means that there were a lot of places, a lot of projects that were simply using BPT for this background processing, because actually light processes did not exist before. And since then, OutSystems actually saw that how the projects were making use of BPT, they actually then extended this BPT with the light version to remove all this complexity that BPT has on the underneath, because it has to create records on the process table, process inputs table, on activities table, on activities input table or activities output table. So there is a lot of things happening there. If you just want to make that in a one light thing, like one simple thread and that's it, then it would simplify everything. And then that's what OutSystems did. So which means that you could simply just um, um, go to your BPT processes that you were doing this before, that you were doing this background processing, and simply make them a light process by changing them to to only have one automatic activity and so on. I recently heard that there is a workaround, not official, to increase the 3 minutes timeout. It seems to be very bad practice, as developers should review the code instead. What is your opinion? I completely agree with you. So um, even if there is a workaround, because this is I believe that this is configurable, but is configurable by OutSystems. I don't think that you can simply go there and change it. You would have to request, but to request you would have to have a very good reason to do this, which I cannot find any, because if it's taking more than 3 minutes, maybe you can create um, a timeout mechanism as you do on timers. But also if it's taking more than 3 minutes, well, maybe it's a reason for you to use a timer. Well, a timer has a 20 minutes, but maybe it's too much. But if it's taking 3 minutes, then either something is wrong or it's actually something very heavy. And if it's something very heavy, then maybe a timer would be the best option. Um, the next one. Is it possible to add administrative functionality to light processes, like perform retry, cancel, etc.? Yes, yes you can. But well, of course, this is all manual and is actually how I explained it. So if I have here my light process and if I want to create kind of a retry mechanism, I can simply, well, if I don't do anything and if it fails, then it automatically has a retry mechanism by itself. So you don't have to do anything because the platform already does this by nature. And if you want to do something to cancel, you can do something as I explained before, which is like this. Um, so yes, so perform a retry. Retry is simply if there is an exception. If there is an unhandled exception, then the platform will retry it automatically. If you just handle that exception and then end that execution with an end, then it will not retry because it will be successful. To cancel is, well, as I explained before. Do you need to do the deploying step for all live processes, or is it handled by the OutSystems platform? It seems very manual and error-prone compared to BPT or timers. You don't have to do anything. So I was explaining separately how light processes work, or how the platform created the triggers and created the records and so on, and event tables. But actually that happens just by you clicking on publish. So whenever you click publish, then the publish will have a couple of steps. So it'll have the uploading step, the compiling step, the deploying step, and during that deploying step is when the platform does all that. Because during the deploying step, the deployment the platform will see all the processes that have conditions that will need to create all those entities, like the event entities and triggers and so on. But you just click one publish and that's it. You don't have to do anything. The platform does everything for you. Yeah, and also you said here for all light processes. Actually, you only create for if I have another process, I only have to publish once because deploying step will go through all of them and does that all at once. So I hope that I explained your that I answered your question. Then the last one. When handling an exception in the flow of light BPT, you used commit transaction to actually update the trigger entity. Won't it also commit other changes that were done by the moment by that moment by the light PPT? Yes and no. Depends how would you have it implemented. Let me just go to the example here. So let me delete this. Let's assume that we have here an exception. So I'm handling that exception, and then I want to store the error message from the last time that this light process failed. Well, I can simply update. Well, first I need to access the record, so I cannot access the record from that entity, from that query. So I'll first create here gen trigger gen report, and then assign that. Okay, and then assign this variable with the result of the query. Now, if there is an exception, I can have access to the content of this variable. So here, now I will update this error message with the exception, and then let me go here, update, and then commit. And then I terminate again with the raise an exception with new user exception, with a new user exception, which I will just again send the exception message. If there was inserts or updates done during the course of this execution, and then there was something that raised an exception, these all exceptions is aborting that transaction. So everything that was done until here will be aborted. And now I'm doing changes. And then I commit, which means that only this will be committed. Of course, if you set here to abort transaction no, then you are right. Then if I do this, everything will be committed, also what was done here. But it's all about how you actually implement this. So typically, I would just put abort transaction to true, and log error, maybe I will set it to false, because this will raise another exception, which I will raise the exception with the exact message that originated this exception. And if I put to log error here, then I'm logging in Service Center 2 errors with the exact same message. So then I can simply put log to false. And this was the last question. So I hope that everything was clear, and I hope that all the questions were answered.